Factors. Let's list the factors of 6. How can we make pairs of numbers that multiply together to make 6? Well, 1 times 6 equals 6. What else can we find here? 2 times 3 equals 6. We could write these as 3 times 2 also equals 6. We could write 6 times 1 also equals 6, but these ones are already written here. So what numbers do we have? 1, 2, 3, and 6. The factors of 6 are 1, 2, 3, and 6. So numbers when multiplied together that give the value we're looking for, those are the factors. And this is a pair, this is a factor pair, this is a factor pair. And we could rewrite them the other way if we wanted to. This is a factor pair, this is a factor pair. So when we're looking for factors, you could list them in a table if you want. So if we wanted to do the factors of 30, for instance, okay, do a bigger number. If we want to do the factors of 30, then we can start off. And so this table will be the first factor, okay, and this table will be the second. So 1 times 30, of course, gives us 30. And now we have to look for all the rest of the pairs. 2, since 30 is an even number, it can divide by 2, and 2 times 15 will also give 30. Okay, so this number times this one equals 30, this number times this one equals 30. 3 times 10, that also gives us 30. We could try 4. 4 times no whole number, no integer, gives us 30. So 4 is not in this list. It has to be a whole number times a whole number. It has to be multiplication of integers. 5, however, is on the list because 5 times 6 gives us 30. And we could keep going because also 6 times 5 is also 30. Like we said, this factor pair is already here though. And the value number 5 and 6 are already here. Okay, so we don't need to write them twice. So once we get to the middle here, once we get to the value that's already been written, then we can stop. Okay, so then we can list our factors of 30, the factors of 30. Okay, we can write them out as 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30. These are the factors of 30. Okay, now, greatest common factor, GCF, you might hear someone call it, GCF. This stands for greatest. Okay, so we're looking for the largest common. That means what is the same? And factors, greatest common factor. Okay, so of course we're going to need 2 numbers to do this if we're going to find something in common. Okay, so if we want to do an example, we could be looking at, let's say, the number 12, and we could be looking at the number 18. So we'll list the factors for 12, and we'll list the factors for 18. When I'm listing factors, I always start with 1 and the last number because, of course, 1 times 12 is going to give me 12. And I leave lots of room in between because I don't know how many there will be, how many other factor pairs I'm going to have to fit inside here. Sometimes it's a lot, and sometimes it's not. So 2 times 6, okay, so again, I'm working my way inside, outside. 2 times 6 is 12. I also know that 3 times 4 is 12. And 5 is not in there because you can't multiply 5 times an integer to get 12. So there's my list of factors for 12. I'll do the same thing for 18. Okay, we'll start with 1 and then 18. We'll leave some room in between. Next, I know that 2 times 9 gives me 18. 3 times 6 gives me 18. Okay, and there's a little gap here, and this happens a lot because really I'm just leaving room. I don't know how many factors are going to fit in between. So I do that, and there's my list for 12, and there's my list for 18. So the greatest common factor, okay, the largest number that's shared between these two. Well, I just look at my list, and they both share 6. The largest number that they both share is 6. So the greatest common factor of 12 and 18 is 6. Okay, So we use greatest common factors a lot with fractions. We will use them to bring them down to their lowest form. So for instance, let's say I had 6 over 8. Let's say I had the fraction 6 over 8, and I want to reduce this to its lowest form. Well, they're both even, and I can divide them both by 2. Okay, so I could go divide by 2 equals 3 over 4. Okay, this is 6 over 8 reduced to its lowest form. Well, I can also use that greatest common factors to do the same thing. Okay, so we'll go back over here. We noticed that when we did the list of 12 and 18, the GCF was 6, okay, the greatest common factor. So now let's see how that helps us with fractions. So if we had 12 over 18, okay, yes, we could slowly reduce it down one at a time to get down to its lowest, most reduced form, right? They're both even numbers, so we can divide by 2. 12 divided by 2 is 6, and 18 divided by 2 is 9. But we can keep going because we can divide 6 by 3 and 9 by 3. Okay, so we can divide these both by 3 still. 6 divided by 3 is 2, and 9 divided by 3 is 3. And now we're down to its lowest form. We can't go any lower than that. So 12 over 18 can be written as 2 over 3. Okay, that's reduced all the way down. However, 12 over 18, we already decided that the greatest common factor is 6, or we found out that it's 6. So if we reduced both of them by the GCF, you can see 12 divided by 6 is 2, and 18 divided by 6 is 3. We go straight to the most reduced fraction. So that's where we use GCFs a lot, to take a fraction and reduce it straight in one step down to its lowest form.